Hey, geometry students, we have new vocabulary for lesson 3-3. We have slope and we have rate of change. So, in a coordinate plane, the slope of a line is the ratio of the change along the y-axis to the change along the x-axis between any 2 points on the line. We call this rise over run. So we have slope m equals y2 minus y1 over x2 minus x1, where x1 does not equal x2. If x1 equals x2, then my denominator would be 0 of my slope, and the slope would be undefined. Here we're finding the slope of the line. We have 2 points. We have point -3, 7, which is up here at S, and then we also have our other point here down at T. Okay? And we're doing a rise over run, y2 minus y1. So -1 minus 7 over -1 minus -3. We end up with -8 over 2 or -4. Final answer, -4. Here we're finding the slope of the line. Well, in this case, our p and our q both have the same x value. They're both at x value of 0. And when we subtract them, in the denominator we get a 0 on the bottom. Therefore, the slope is undefined. Here we're finding the slope, and it looks like the slope is going to be positive since it is going to the right and up. And so we have our 2 points, -2, -5, and 6, 2. Doing the rise over run formula, we end up with a substitution of 7/8 as our final answer. So we have a slope of 7/8. Find the slope of a horizontal line. In a horizontal line, the y values are the same. So in this case, both y values are -1. Therefore, my numerator of my rise over run will be 0. And we end up with 0 over 8, or the final answer of 0. So all horizontal lines have a slope of 0. In all vertical lines, slopes are undefined. Check your progress. Find the slope of the line. Now please pause your video. The answer is -3/5. Check your progress. Find the slope of the line. Please pause your video. The answer is 0. C. Find the slope of the line. Check your progress. So please pause your video. The answer is 2. Check your progress one more time. Pause your video. We have a slope that's undefined. Classifying slopes. We have positive slopes going up and to the right, negative slopes going down and to the right. Zero slopes are horizontal lines, and undefined slopes are vertical lines. Here's a real-world example using slope as a rate of change. In 2000, annual sales for one manufacturer of camping equipment was $48.9 million. In 2005, the annual sales were $85.9 million. If sales increase at the same rate, what will be the total sales in 2015? So we have a slope. We're going to find the slope between the 2 points, 0, 48.9 and 5, 85.9. We're letting 0 represents the years since 2000. Since we're starting at 2000, then we have that ordered pair called 0, 48.9. So there's the graph that represents the situation. Now we're going to find the sales in 2015, and we can make an estimate by looking at the actual graph. Okay, so if you go out to 2015, looks like somewhere right around in here. Okay, so you can come across and think about where that answer might be, somewhere close to 150 and less than 175 million. So we're going to find the slope of the line. So we're going to do our rise over run, and we end up with a 7.4. Okay, what that means is that the amount's going to go up by 7.4 for every year. The sales increase an average of 7.4 million per year, assuming its constant rate. Using the slope of the line and one known point on the line to calculate the sales y when the years x since 2000 is 15, we end up with solving for the y2 being the 15 minus 0 on the bottom. 15 being the 15 years since 2000. And so we can actually solve for the y2 by simplifying, multiplying each side by 15, and then solving for y2 by adding 48.9. So we have y2 is 159.9. Just like we said in the example when we said that the answer probably is going to be somewhere between, in our graph, okay, go back a couple, we said the answer would be somewhere between 150 and 175, and we were close, about 160 million. All right, real world example number 2. Check your progress. Go ahead and pause your video and try to answer the question. The answer is about 251.5 million. All right, postulates, parallel and perpendicular lines. Slopes of parallel lines, two non-vertical lines, have the same slope if and only if they are parallel. All vertical lines are parallel. So parallel lines L and M, over here in the graph, have the same slope. They have a slope of 4. Slopes of perpendicular lines, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So we have line M is perpendicular. Notice the notation we use for perpendicular. Line M is perpendicular to line P. The products of their slopes, 4 and -1/4, ends up equaling -1. All right, we're going to determine whether of line FG and line of HJ. So we have a slope of -2/3 for line FG by doing our rise over run. And then the slopes are not the same, so line FG and line HJ are not parallel, and the product is not -1, ends up being -2. So they're not perpendicular either. So the lines are neither parallel nor perpendicular. When graphed, you can see that the lines are not parallel and do not intersect in right angles. Check your progress. Please pause your video and decide if these lines are parallel, perpendicular, or neither. The answer is that they're perpendicular. Graph the line that contains 5, 1 and is parallel to line MN with M at -2, 4 and N at 2, 1. So let's find the slope of MN. So find the slope. We end up with a substitution using our rise over run with a -3/4. So we have a slope of -3/4. Now, when we go to the two parallel lines are the same. The slope of the parallel lines through 5, 1 is -3/4. Graph the line. There's our MN and there's our 0.51, but we also must have a slope of -3/4. So from that point, right, we can go, if we want to, we can go up 3 from Q, 1, 2, 3, and then over 4, 1, 2, 3, 4. And we can plot a point right there and then connect them. And we'll label that point, and we draw the line in.